We're asked to solve an equation like this, where there's fractions involved. We'd like to, if possible, get the fraction part of the problem gone. So there's two major techniques for doing that. Both of them involve identifying a common multiple. So we need a common multiple of the denominators. Ideally, you'd like it to be the least common multiple, but it does not have to be. It could be any multiple of them. So on the side, you could list their multiples. This is of the denominators. We don't really care what the numerators are at this point. So what are the multiples? We got 3s, we got 6s, and 8s appearing in our problem. You want to list their multiples. So 3's multiples would be 3, 6, 9, 12, 15, 18, 21, 24, and so on. 6's multiples would be 6, 12, 18, 24, and so on. 8's multiples are 8, 16, 24, and so on. So in the list here, I can see that we have a common multiple. It's 24. That is what is known as the least common multiple because it's the first multiple that came up. So let's write that down. Now, we have an option of how we proceed at that point. You could do one of two major techniques. You take that LCM and you decide which approach is best for you. One of these approaches involves putting parentheses around both sides of the equation and multiplying the LCM on both sides. So multiplying both sides by the LCM. The other approach is very different though. In this approach, we introduce the multiplication of a fraction times every term in the problem. And the goal of this is to get the denominators to become the LCM. So I like to show both methods because people learn differently and people have success with different strategies. You know, one size does not fit all here. But I'm going to go over both approaches. Okay, so with the left side here, we would want to multiply by that LCM of 24. So just put a 24 on both the left and right. With this approach, we have to distribute the 24 to all terms. So send the 24 here and here. And we'll send this 24 there and there, so every term gets multiplied by 24. If you wanted, you could basically write it like this. 24 gets multiplied by everybody. When we multiply those things, they're all going to cancel to just integers. So on calculator, you do 24 times 2 over 3 makes 16. So we have that. Then we'll do 24 times 1 over 6 and get 4. 24 times 5 over 6 makes 20. And we get 3 for that last term. And then it would be solvable. So subtract your 16x. Get 4x equals 1. The answer is 1/4. Okay, that's a major way of solving these fraction equations. It's not the only way though. The other way is to build your fractions to higher terms. Okay, by figuring out 3 times what makes the LCM. Because we're trying to create the LCM here. So 3 times something will do that. Our LCM is 24. That's what we need to make, so we have to figure out what goes in that space. So the answer here, if we divide both sides by 3, that reveals that the thing that goes there should be 8. So since 24 is 8 times 3, that means that we need to put 8 over 8 into that fraction. And that's what this technique's about. It's about just picking the right choice so that your denominator, after we multiply, 8 times 3 will become the LCM of 24. The numerator here would become 8 times 2, which is 16. So it's going to be like 16. And then there's an x as well. So we'll have that. Do the same thing here. So 6 times something makes 24. The answer here would be 4. So we have to multiply by 4 over 4. This is going to be the same. 4 over 4. And here we'll have 8 times something makes 24. And the answer is 3. So multiply by 3 over 3. Alright, so what do our fractions become? They all have denominators of 24 now. We would want to multiply straight across. 4 times 1 makes 4. 4 times 5 makes 20. There's also an x in that term. And then 3 times 1 makes 3. Now, once you have all your denominators the same, we can use this useful technique of just canceling them off. In an equation, when you have everybody being divided by the same thing, you can get rid of it just like you would if you were to multiply all sides by 24. Those 24s would now cancel with the 24s below. So you'd get 16x plus 4 equals 20x plus 3. Obviously that is the same equation as what I found on the left, so it's going to have the same solution.